Hey guys, welcome back to Math Principles. Last time we were together, we were looking at solving quadratic equations by factoring. We saw that some of those quadratics didn't exactly factor, so we need some other approaches that will enable us to solve those as well. So one of those approaches that we're going to look at right now is something called completing the square. Okay, now first off, what does completing the square mean? Well, completing means you're putting in a missing piece, and as for the square, we're talking about a squared binomial. So below here, we have four squared binomials. The quantity x minus 4 squared, the quantity x plus 9 squared, and x plus 6 squared, and x minus 3 squared. Okay, now, each one of these, we want to look at what we get when we carry out that arithmetic. Okay, so first off, what it means to square something is not just, I'm sure if I told you guys to do this yourselves, someone out there is going to say that this is equal to something that's not showing up. Oh, here we go. And the right color, there we go. Okay, this is going to equal x squared minus 16. Because they squared the x, they squared the 16, and they keep the minus sign between them. But that would definitely be incorrect. What we actually have to do here, to square something means to multiply it by itself. So what we would do is write it out twice. Quantity x minus 4 times the quantity x minus 4. Okay, we write that out twice, and we actually carry out that multiplication. Okay, now if I FOIL this, x times x gives me x squared. If I do x times minus 4, that's going to give me minus 4x. If I do the inside minus 4 times x, that's going to give me another minus 4x. And if I do on the outside negative 4 times negative 4, that's going to give me plus 16. Okay, now I can combine my like terms, these two minus 4x's, and have x squared minus 8x plus 16. Okay, and I can do the same thing here with the x squared plus 9, or excuse me, x plus 9 quantity squared. Okay, write it out twice, x plus 9, x plus 9, okay, and then FOIL it, okay? X times x gives me x squared, plus x times 9 gives me 9x, plus 9 times x gives me another 9x, and then finally, 9 times 9 gives me 81. And I can combine my like terms again and have x squared plus 18x plus 81. And I can do the same thing with these two as well. Now, in the interest of time, I'm going to cut to the chase with each of these. If I write them out twice and FOIL them, I'll get x squared plus 12x plus 36. Ooh. Okay, and if I square this one over here, I'll have x squared minus 6x plus 9. Now, each one of these have a very special relationship between the b coefficient and the c term. Okay, so if I look at this minus 8 and compare it with this 16, I look at this plus 12, compare it with this 36, look at this plus 18, compare it with 81, and look at this minus 6 and compare it with 9. Now, normally in class, what I'd have you guys do is sit in teams and try to figure out what the pair is, what the relationship is. Well, we don't really have that option right now, so I'll just tell you. Okay, this right here is the B, and this is C. Okay, and C in a perfect square trinomial is always going to be equal to B divided by 2 squared. Every single time, that is always what it's going to be equal to. So we can use that to complete the square, to take a quadratic that's not factorable and make it factorable. Now, the first couple that we're going to look at are definitely factorable. They're going to get us integer answers. That's how we know they're factorable. But we're going to work with ones that we understand how to do first, or ones that are a little bit easier to do first before we get into the more difficult ones. So if I want to complete the square, I'm going to be given a trinomial, something like this. Example 1, x squared minus 12x plus 11 equals 0. The very first thing that I want to do is move all of my constants to one side and variables to the other. So I want all the x's over here, and I want all the constants over here. The next move is going to be to add that b over 2 squared to both sides of the equation. Okay? Now, on the left side, I'm going to put exactly this, what we see. And on the right side, I'm going to simplify that expression a little bit. Okay, then I'm going to factor. And it's always going to factor the exact same way. X plus b over 2, the quantity, squared. So whatever was in here before we squared it, that goes in the parentheses with x. Now, it might not be equal to 0, though. Sometimes it'll be equal to 0, but most of the time not. So it's equal to something else. We'll call it g. It's equal to some number g. Now, then, once I have that set up, I can solve that equation. So let's take a look at some examples. Okay, this first one here, I have x squared minus 12x plus 11. The very first thing that I want to do is get all of my constants on one side, so I'll subtract that 11 from both sides. Okay, and that will give me x squared minus 12x, I'm going to leave a little bit of space, equals negative 11. Okay, now I'm actually going to move all that over just a little bit, give myself a little space for example 2. So x squared minus 12x, leave a little bit of space, equals negative 11. Okay, now the next step, I need to add b divided by 2 squared to both sides. I'm going to add something divided by 2 squared. Now b is whatever's multiplying x. So in this case, it's that negative 12. Now that minus sign is really important. We don't want to lose it. It's going to be really, really important later on. Don't lose that minus. Okay, now, negative 12 divided by 2 is negative 6. And negative 6 squared is 36. Okay, so these two things in green are the exact same value. Negative 12 divided by 2 squared, positive 36, exact same thing. Now, I am going to clean that up a little bit so that we can see what we're working with. Okay, and we'll have x squared minus 12x plus 36 equals negative 11 plus 36 is 25. Okay, now we're going to factor this left side. Okay, and this left side is always going to factor exactly the same. X plus whatever was in those parentheses before we squared it, quantity squared, still equal to that 25. Now, what was in those parentheses before we squared it? Okay, well, negative 12 divided by 2 is negative 6. Now, the one little detail that I would change here, I would clean this up for myself, I would say x minus 6, the quantity squared, still equal to 25. Okay, now, right here, we have completed steps 1, 2, and 3. Step 4, solve. There's a few steps involved in it. Okay, what we have, I want to get this x all by itself. This x is being subtracted by 6, then squared, and it's equal to 25. So I need to work backwards to undo each of those things. So the last thing that happened was it was squared. So the first thing that we'll do is we'll unsquare each side. We'll take the square root. Okay, and when I take the square root, on the left side, the squared and square root cancel, and I just have x minus 6. On the right side, the square root of 25, now this is really important. Everyone can tell me that the square root of 25 is 5, but it's actually plus or minus 25, because either 5 or negative 5 can be squared to give us that 25. So now I have x minus 6 equals plus or minus 5. So right here, I'm actually going to have two separate equations. I have x minus 6 equals 5, and x minus 6 equals negative 5. And we have to solve each of them. So here on the first one, I'll add that 6 to both sides, and I'll get x equals 11. And then over here, I'll add 6 to both sides, and we'll get x equals 1. So my solution set is x belongs to the set consisting of 11 and 1. And there we go. Okay, let's take a look at example 2 here. Okay, example 2 is going to start out the exact same way. First thing I want to do is move all the constants to one side. So I'll have x squared plus 4x and I'll leave a little bit of space, is equal to 0 plus 5 is 5. Now, I want to add something to both sides. So I want to add something divided by 2 squared to both sides. Now, what this something is, it's whatever was next to the x. Okay, not x squared, but x. Okay, so that's 4. Now, 4 divided by 2 is 2, and 2 squared is 4. Okay, so on the right side, on the left side, I have x squared plus 4x plus 4 divided by 2 is 2, squared is 4, equals 9. Now this, we want to factor this, and it will always factor the exact same way. X plus whatever was in those parentheses before we squared it, quantity squared, equals still 9. Now, what was in those parentheses before we squared it? Well, 4 divided by 2 is 2. So I have the quantity x plus 2 squared equals 9. Now, on this one, on the first one, I had right here okay, I had x plus a negative 1, or negative 6. And we don't like to have plus and negative, so I changed it to x minus. But here, I don't have that problem. So I can get right to solve it. Okay, so the first thing I want to do, they are adding x by 2 and then squaring it. So I'm going to work backwards and undo each of those. So the last thing they did was square it. So the first thing I'll do is the opposite of squaring. I'll take the square root. Okay, the squared and square root cancel one another out. We just have x plus 2 equals, the square root of 9 is plus or minus 3. Okay, but when we take the square root, remember, you're always going to have a positive and a negative root. So we always need to make sure that we have both of those accounted for, because right now, we need to make our two separate equations. So we have x plus 2 equals positive 3, and x plus 2 equals negative 3. Okay, and now we solve each of these. Okay, so I'll subtract 2 from each side. And that will give me x equals 1. And then I'll subtract 2 from each side here. And that will give me x equals negative 5. Okay, so our solution set is x belongs to the set consisting of 1 and negative 5. Okay, and here we go. All right, so move all the constants to one side, variables on the other, add b over 2 squared to both sides. Then we factor x plus b over 2, the quantity squared, equals whatever we had on the right side. And then we solve it. Just remember that when we solve, we have to remember the plus or minus when we take that square root. Okay, let's take a look at a couple more examples. Okay, I have x squared minus 24x plus 23 equals 0. So the first thing that I want to do is get all of our constants onto one side. So I'll subtract that 23 from both sides. Okay, and that will give me x squared minus 24x, I'll leave a little bit of space, equals negative 23. Okay, now I need to add something to both sides. I want to add b divided by 2 quantity squared. Okay, now b is whatever was multiplying x. And that right here, this is 24x. Okay, so negative 24 divided by 2 is negative 12. Okay, we don't want to lose that negative because it's going to become really important later on. Okay, now, negative 12 divided by 2 is negative 6, and negative 6 squared is 36. Okay, so now, oops, sorry, a little bit of a mix-up there. Okay, here we go. This is negative 24 divided by 2, so not negative 12, got ahead of myself, negative 24. Now, negative 24 divided by 2 is negative 12, and negative 12 squared is 144. Okay, so we got some big numbers here. No big deal, that's fine. We can handle it. Okay, so the next thing that we want to do, I'm going to clean this up just a little bit. So it's a little bit easier for us to see and a little easier to work with. We'll have x squared minus 24x plus, okay, we said this is 144 equals negative 23 plus 144 is going to be 121. Okay, now this is going to factor, and it's always going to factor the exact same way. X plus whatever was in those parentheses before we squared it, quantity squared, equals whatever's over here. Okay, now look at what was in those parentheses before we squared it. Before we squared it, we had negative 12 divided by 2, excuse me, did it again. Negative 24 divided by 2, which is negative 12. Okay, now I have plus and negative. We don't like to keep that, so I'll make this x minus 12 quantity squared equals 121. Okay, now we've completed steps 1 through 3. We have completed the square. Now we need to finish the solving. Okay, so we take the square root on each side. Okay, on the left side, the squared and square root cancel, and I just have x minus 12. On the right side, the square root of 121 is plus or minus 11. Okay, don't forget that plus or minus, because right now I need to make my two separate equations. X minus 12 equals 11, and x minus 12 equals negative 11. Okay, now I solve each one of these, so I'll add 12 to both sides, and I get x equals 23. Add 12 to each side, and I get x equals 1. Okay, so then I have x belongs to the set consisting of 23 and 1. Okay, and there we go. All right, let's take a look at one more over here. Okay, I have y squared minus 5y plus 8 equals 4. So the first thing I want to do is move all of my constants over to one side. So I'll subtract that 8 from both sides. And I'll have y squared minus 5y equals, leave a little bit of space, equals negative 4. Okay, now I want to add something to both sides. I want to add b, which is negative 5, divided by 2 squared to both sides. Okay, now negative 5 does not evenly divide by 2. That's okay. We still use exactly the same process. So if I come over here and I take negative 5 and I divide it by 2 and I square it, well, to square something means to multiply it by itself. So negative 5 halves times negative 5 halves, we multiply straight across and we get 25 fourths. Okay, so that's what I need to add right here. So plus 25 over 4. Okay, now on the left side, clean this up a little bit, and we'll have y squared minus 5y plus 25 over 4 equals, okay? Now, over here, I've got negative 4 plus 25 fourths. And I need to have a common denominator. Whoop. In order to add those together, I need to have the same thing under both 4 and the 25. Geez. I'm a little trouble here with this pen. Okay, so if I have negative 4 and I want to write that with a common denominator, that'll be negative 16 over 4. Okay, negative 16 divided by 4 is negative 4. They're the same thing, they just look a little bit different. Now, on the left side, I can factor this, and it's always going to factor exactly the same way. Y instead of x this time, plus whatever was in these parentheses before we squared it. So that was negative 5 halves. Quantity squared equals negative 16 plus 25 over 4 is going to be a positive 9 over 4. Okay, so now I want to solve. So I want to get that y by itself. It's being, well, actually before I solve, I might clean this up a little bit. Instead of plus a negative, I might do y minus 5 halves, quantity squared, equals 9/4. Okay, now I'll take the square root on each side. Okay, on the left side, I'll just have y minus 5 halves. Okay, on the right side, if I want to square root a fraction, here's a little trick. Just square root the top. Okay, so the square root of 9 is 3. Square root, that doesn't look much like a 3, does it? There we go. Square root of 4 is 2, and don't forget that plus or minus out front. Okay, so I have y minus 5 halves equals plus or minus 3 halves. So make our two equations. Y minus 5 halves equals 3 halves, and y minus 5 halves equals negative 3 halves. Okay, so I'll add 5 halves to each side, and I'm going to write that over here as well. Okay, now y is all by itself. 3 halves plus 5 halves is 8 halves. Okay, over here, y is all by itself. Negative 3 halves plus 5 halves is 2 halves. So y belongs to a set consisting of 8 over 2 is just 4, and 2 over 2 is just 1. And there we go. All right, we got one more example for you. This one's a little bit tricky, so stay with me here. Okay, the first thing we're going to do is the same thing we always do. As a matter of fact, all of the steps are the same thing we always do. Start by getting the constants all on one side. So I've got x squared minus 8x, leave a little bit of space, equals negative 6. Okay, and I'm going to move that all over again. X squared minus 8x, leave a little bit of space, equals negative 6. There we go. All right. Now, I want to add something to both sides. Okay, and what I want to add is that b, negative 8, divided by 2 squared. Well, negative 8 divided by 2 is negative 4, and negative 4 squared is 16. So, on the left side, I can rewrite this a little more cleanly. X squared minus 8x plus 16 equals negative 16 plus 16 is a positive 10. Now, the left side will factor, and it always factors the exact same way. Okay, x plus whatever was in those parentheses before we squared it. So what was in those green parentheses before we squared it? Negative 8 divided by 2 is negative 4. Okay, and then on the right side, it's still equal to 10. Now I'd probably clean this up just a little bit, okay, and say x minus 4, the quantity squared, equals 10. Okay, now I want to get that x all by itself. So right now, it's being subtracted by 4 and then squared. So I need to go backwards into the opposite. So I'll take the square root on each side. Okay, on the left side, I've got x minus 4. On the right side, the square root of 10. Well, there is no integer square root of 10. We get a big ugly decimal. So I'm just going to leave it plus or minus the square root of 10. Okay, now this square root of 10, that's a crazy decimal, and I really don't want to mess around with it, so I'm going to leave it as this radical. Okay, now I need my two separate equations. X minus 4 equals 10, or equals square root of 10, and x, actually we can do this a little bit more cleanly. When we get to a situation like this, okay, where all we have is the square root, okay, and there's nothing else that we can really do, we don't really need to make two separate equations. We can just add that 4 to both sides. Okay, and we'll have our answer listed as x equals 4 plus or minus the square root of 10. okay? And this is actually a perfectly acceptable solution because this square root of 10 is a crazy ugly decimal, and this is exact, okay? Instead of rounding that decimal, even if the calculator shows us 10 digits, that's still an estimate. This goes on forever. So leave it underneath that root and have 4 plus or minus the square root of 10, and that is the answer. Now, the question is, how do I know whether I can leave it in this form when I have to make two equations? Well, that answer is very simple. When you take that square root on each side, if you have, when you take that square root on each side, if you're stuck with a square root, you can't reduce that square root to an integer, then you can leave it in your answer and just add whatever this is to both sides, get that x by itself, okay? So on all of these, the first thing that we want to do is move all the constants to one side, variables to the other. Add b over 2 to both sides. And when you're looking at that b, make sure if that b is negative, like this one is here, make sure you keep that negative inside those parentheses. When you square it, it'll be positive, okay? But when you're working with it in these factors right here, okay, we need it to be negative. Especially when, and that's where step 3 comes from, because that b, if that b is negative, then this plus sign right here in your factor can become a minus sign. Okay, then once you have it in this form, you just solve. You take the square root on each side and you get the x all by itself.